Welcome to class 8 mathematics classes. Today's chapter is rational number. Chapter number 1, rational numbers. We have studied about natural numbers. Natural numbers, whole numbers, integers, fractions in lower classes. So, what are natural numbers? Natural numbers are counting numbers starting with 1, 2, 3, 4, and so on. Whole numbers includes 0 and counting numbers 1, 2, 3, 4, and so on. Integers, all the negative numbers, 0, and all the positive numbers. Fractions, we have studied two types of fractions. One is proper fraction and another is improper fraction. Proper fractions are less than 1, where you can see numerator is less than denominator, and in improper fraction these fractions are greater than 1 and numerators are greater than denominator. Now today we are discussing about rational numbers. So any number in the form a by b where b is not equal to 0, that is denominator is not equal to 0. If denominator is 0, then this will be undefined. This will be undefined. A can be 0 but b cannot be 0. Examples of few rational numbers like 1 by 2, 3 by 2. Okay, so 1 by 2 is proper fraction. You can see here numerator is less than denominator. The value of this is less than 1. Improper fraction, you can see here the example where numerator is greater than denominator and the value is greater than 1. It can be numerator can be equal to denominator also in improper fractions. Negative and positive rational numbers. Negative and positive rational numbers, like in integers, that numbers which are greater than 0 are positive numbers and less than 0 are negative numbers. So in the same way, in rational numbers also, the numbers which are greater than 0, okay, are positive rational numbers, and numbers which are less than 0 are negative rational numbers. Suppose a by b is a rational number and is less than 0, then a by b is a negative rational number. Or a by b is greater than 0, then a by b is a positive rational number. Example, of negative rational number is minus 1 by 2 or 1 by minus 3. The negative sign, whether it is in numerator or in denominator, doesn't make any differences. In these two cases, both are negative numbers. Now, examples of positive numbers, positive rational numbers: 1 by 2, 2 by 3, like this. Absolute value of a rational number. Absolute value of a rational number. So any number, for example, minus 5, this is a rational number. If we put 1 here, it gives a by b form, and the value also doesn't change. So absolute value of minus 5 we write like this way: mod minus 5, and it will be equal to 5. The negative number becomes positive number, isn't it? So the sign is having no meaning here. Similarly, absolute value of minus 2 by 3 will be equal to what? Will be equal to, absolute value of minus 2 by 3 will be equal to 2 by 3. Standard form of a rational number. Standard form of a rational number. Okay. Suppose a by b is a rational number, then we can say that this is in standard form if this is in standard form if the HCF of A and B is 1. For an example, say 16 by minus 72. Okay, we have to express in standard form. Okay. So here the HCF of, first of all we have to make it positive number. Okay, denominator should be positive. So we can write this one as minus 16 by 72. Yes or no? Now the HCF of 16 and 72 we have to find. So we can go for a rough work to find this. In 16 and 72, 16 is the smallest, so we'll divide by the smaller. So here how many times it goes? 16, how many times it goes? 16 4 times it goes, 64, and remainder we are getting here 8. So this 16 will divide by 8, 8 2s are 16. So therefore HCF of 16 and 72 is 8. HCF is equals to 8. With this HCF With this HCF, we have to divide numerator as well as denominator to get the standard form. So here 8 2 times 16, so minus 2, 8 9 are 72. So this is the standard form. Now next is equivalent rational numbers. Equivalent rational numbers. Suppose if we have a rational number a by b, then this will be equal to a into m and b into m. So this m is a positive number or a negative number, but not 0. Okay, it can be any integer except 0. If you multiply the numerator and the denominator by the same integer except 0, then what we obtained is equivalent to the rational number given. Okay, so similarly, if we divide the numerator and the denominator by same integer, then whatever we'll obtain will be equivalent to the given rational number. For example, suppose we have 1 by 2 as a rational number, and if we multiply the numerator by 2 and the denominator by 2, what we'll obtain will be equal to this only, as this will get cancelled and the standard form will become 1 by 2 only. Similarly, if we multiply numerator and denominator by 3, still we are getting the same equivalent rational number, that is 1 by 2. And we divide. For divide, suppose a rational number 8 by 16 is there, and we divide it, numerator by 2 and denominator by 2. What we obtain will be equal to 8 by 16 only, isn't it? It will be equivalent to 8 by 16, as this will also cancel and it will also come as 8 1s are 8 2s are 1 by 2. So again, if we divide it by 4 and denominator also by 4, still the value will not change. You can see my work, as it was not captured by the camera. Now just see, here I can show you. This is the example. 1 by 2 is a rational number, and if you multiply the numerator by 2 and denominator by 2, the value we obtain will be equal to 1 by 2 only. Similarly, if we multiply by the same number 3 in the numerator, 3 in the denominator, then still the value will not change. Now another example, 8 by 16, here we are dividing numerator and denominator by the same number, the value will not change. Here also we are dividing the numerator and denominator by same number, that is 4, and the value remains same. So this is what equivalent rational number. Now methods to check the equality of two rational numbers. Let us see method to check the equality of two rational number. Suppose we have two rational number a by b and c by d. Now, to check the equality of this number, we have to suppose that a by b is equals to c by d. Now, if we get this a into d is equal to c into b, then these two, then a by b will be equal to c by d. Otherwise they are not equal. A by b will not be equal if a into d is not equal to c into b. So, for an example, suppose we have minus 4 by 13 and 8 by minus 26, and we are checking the equality of these two rational number. So, what we have to do is, first we have to suppose they are equal. Let they are equal. Now, what we have to do is minus 4 into minus 26 and 8 into 13. We have to check this one. When you are doing minus into minus is plus, 26 into 4 will be 6 4s are 24, 4 here, 2 on hand, 4 2s are 8, 104. So, this side we got 104 and 13 8s are 104. So, both the sides we are getting equal. Therefore, minus 4 by 13 is equal to 8 by minus 26. If we do not get these two values equal, then we cannot write these two as equal. Now, comparison and ordering of rational number. Comparison and ordering of rational numbers. My dear students, here few steps are involved. Step wise we have to do. Step 1, first of all we have to write all the given rational numbers with positive denominators. In step 2, we have to find the LCM of the denominator. LCM of the denominators in fact. Now, step 3, we have to express each rational number as an equivalent rational number. Express each rational number as an equivalent rational number. This can be done with the help of this LCM that we have found. Okay. And step number 4 is the answer, where we have to compare the numerators that we have obtained in step number 3. The greater the numerator, the greater is the rational number. Greater the numerator, greater is the rational number. So with an example we can see here. Now let us compare 3 by 4 and 5 by minus 6. According to step number 1, first we have to make the number, that is the denominator, as positive. So how to make 3 by 4, and simply we can shift this minus sign to 5 and this becomes positive denominators. Now next is to find the LCM of 4 and 6. LCM of 4 and 6, how much? 3 2 ja 6, 6 2 ja 12. So 12 is the LCM. Now with this LCM we have found the LCM, step number 2, LCM is equal to 12, isn't it? So now we have to express this equivalent, we have to make it equivalent fractions by multiplying with this 12. So here how much? 4 1s are 4, 3s are 6 1s are 6 2s are. So here is 3 3s are 9 and this one is minus 10. So now we can easily understand which one is greater. Okay, 3 by 4 is greater and 5 by minus 6 is smaller, isn't it? So ordering we can write, we can write 3 by 4 is greater than 5 by minus 6. If we want to arrange it ascending, then we should write 3 by 4 comma 5 minus 6. This one is a small example. We will do the exercises in clear manner. Representation of rational numbers on the number line. Now how to represent a rational number on a number line. Let us draw a number line. Okay, at the middle of number line 0 is there, so let us mark it as O, and this is 0. And let us mark a point A on the right hand side of 0 and A dash on the left hand side of the 0. This side positive numbers are there and this side negative numbers are there. Suppose let us try to represent 5 by 8 and minus 3 by 7 on the number line. So this fraction, if you see, it is 5 out of 8 equal parts, and this is a positive fraction, 5 out of 8 equal parts. So we have to divide this into 8 parts. Okay, 8 equal parts. Try to make it equal. So suppose this is 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and this fraction you can see here, this is minus 3 out of 7 equal parts, and this is a negative fraction, so it will be this side of the 0. So 7 equal parts we have to make. So 1, 2, 3, 4, 5, 6 and this is 7. Count once. 1 2 3 4 5 6 7 8 parts this side. This side 1 2 3 4 5 6 7 parts this side. So this is 1, this is 1 by, this is 1 by 8. Let me write here 1 by 8, 2 by 8, 3 by 8, 4 by 8, and this is 5 by 8. So this is the fraction 5 by 8. Okay, this is on the number line, and this one is minus 1 by 7, minus 2 by 7, this is minus 3 by 7. So this is the number on the number line, minus 3 by 7. So here we have done the clear concept of rational number to do exercise 1.1. In the next video class we will do exercise 1.1. Thank you.